The quotient rule allows you to take the derivative of a quotient or a fraction of two functions. It's quite a complicated formula, but it kind of resembles the product rule to start with, where in just the numerator, you take the derivative of the top, and then you multiply by the bottom, you leave the bottom alone. You then subtract instead of add, and then over here is the opposite of what we did here, where you leave the top alone, but then multiply by the derivative of the bottom. You start with a fraction, and so there's a fraction in your answer, and the denominator is the square of this denominator. What I like to do is apply this rule to this example. So here we have a fraction, e to the x in the top and x squared in the bottom. And according to this rule, you would start by taking the derivative of the top, which is e to the x. E to the x is its own derivative, and then you multiply by the bottom, so you just leave the bottom alone. You then subtract off, okay, now you leave the top alone, but then multiply by the derivative of the bottom. This whole thing is divided by the denominator squared. So that'd be x squared squared. Of course, you could simplify this. Let's see, in the numerator, you can factor out an e to the x as well as a single x. So I'll put, okay, this is really x e to the x, and what is left over is x, and then minus 2. And your denominator, if you're squaring x squared, that is x to the fourth. I see that there's an x to the first in the top and an x to the fourth in the denominator, so I can cancel this x, provided that I reduce this down to a 3. And so my completely simplified answer would be, okay, that's e to the x times x minus 2 all over x cubed, and this would be the completely simplified answer. Now, we already did this problem, but for example 2, I want to differentiate this function, but without using the quotient rule. The way you can do this is by rewriting it so there's no fraction. You can move x squared to the numerator as long as you make the exponent of 2 negative. So, just a reminder, we already have the answer. It's e to the x times x minus 2 all over x cubed. But another way that you can solve this is by doing this instead. We'll take the derivative of x to the negative 2 times e to the x. So you can use the product rule here because we have one function, x to the negative 2, being multiplied to another function, e to the x. According to the product rule, you would take the derivative of the first, which is negative 2x to the power of negative 3. Then you leave the second thing alone. You add on the reverse of the situation. That is x to the negative 2 times the derivative of the second, which is, well, e to the x. All right, this is the answer, but let's try to make it look like this just to show that these two methods are the same. The way I'll do that is by getting rid of these negative exponents. So I can change this to, all right, this is really negative 2 times e to the x all over x to the positive 3. And then here I have e to the x over x to the positive 2. I want a common denominator. So essentially, I'm going to multiply this by x over x. That'll give me a common denominator of x cubed. So I have my common denominator. My common denominator is x cubed. Here, I didn't change the fraction, so I'll just put negative 2e to the x. I'll add on, over here I did change it, and I'm going to add on, I'll put x e to the x, like this. These things don't look the same, but you can factor out e to the x from both terms. If I do that, I get e to the x, and I get negative 2 plus x left over. Of course, I'm going to just change the order, so it's e to the x times x minus 2 all over x cubed. And that is exactly what we got when we use the quotient rule. So either method's fine. So for this question, I guess you really didn't need to use the quotient rule. You could use the product rule, and you will get the same answer. So let's try one more example. So I want to take the derivative of 3x plus 1 divided by 2x minus 4. For this one, I think we will, for what we know, need to use the quotient rule. So let's try it. All right, so the quotient rule says that we take the derivative of the numerator, which is 3, and we multiply by the denominator, which is 2x minus 4. We then subtract off the reverse of this, where I leave the numerator alone, and then multiply by the derivative of the denominator, which is 2. This whole thing is divided by the denominator, which is 2x minus 4 squared. This is it. This is the derivative. It's customary when dealing with the quotient rule to leave the denominator squared instead of multiplying this out. This will often not accomplish much if you square the denominator. But in the numerator, I can see there's going to be some like terms that could cancel. So I see if I multiply in the 3 and I multiply in this 2, I'll have both some x terms and some constant terms that could be multiplied together. Here's how I like to work through it. Okay, I'm going to have a big fraction. Let's think about the x's that we get. Okay, here we get 3 times 2x, so that is 6x. And then we also get 3 times negative 4, which is negative 12. Now, if we think about the x's that we get over here, we get another 6x, but it's negative, so I'm going to put negative 6x. Here I multiply in this 2, I get a positive 2, but this makes it negative, so I get negative 2. And again, I get the denominator squared. Okay, I see that the 6x and the negative 6x cancel. I have a negative 2 and a negative 12, which combines to give me negative 14. So I get negative 14 for my numerator, and my denominator is 2x minus 4, and that is squared. And this is the final answer by using just the quotient rule.